All right, guys, we are into your first lesson of calculus, and hopefully it's actually really easy because hopefully it's review. We are talking about slopes of lines, okay? So first we're going to talk about what a slope is. You might say, well, it's rise over run, it's y2 minus y1 over x2 minus x1, or change in y over change in x. Those are all like really nice, pretty definitions, okay? But like, what is a slope really telling us about the line? What do we really get to know about the line when we hear the slope? Well, we're finding out how fast that line is changing, right? We're finding out the rate of change of the line. So we're finding out how fast is y changing with respect to how fast x is changing, okay? So this is a really important concept to remember in calculus, even though it's something that you've probably like thought about before. But it's just important to talk about the fact that a slope is a rate of change, because later on in calculus we're going to talk about derivatives, and really that's all about rates of change. So let's figure out some slopes. Okay, so we have the slope of this line here, and again, a slope has a constant rate of change, or sorry, not a slope, a line has a constant rate of change. It has a constant slope. You know, every time it goes up 1, it goes over 1. Every time it goes up 2, it goes over 3. It doesn't ever change no matter what points you pick on the line. So if I pick this point here and this point here, I can count over and see what my slope is. Well, I go over 1, 2, 3 in the negative direction, and then I go up 1, 2, 3, 4 in the positive direction. So now my slope is rise over run, so my slope is negative 4/3. Okay, now let's look at this one. We could look at this formula right here and we could plug it in, but let me tell you, I don't love formulas because you have to memorize them and you have to remember when to use them and you have to remember where things go. So with a slope, we should be able to think of this intuitively. So let's look at this. Here's our y, this is our rise. We want to know how much it's changing. The rise is changing. Well, it starts at 0 and then it goes to 2. Well, if I'm on a number line and I start at 0 and I go to 2, I changed 2 in the positive direction, right? And now if I start at negative 2 and I go to 4, I changed positive 6. Right, because I went from negative 2 to positive 4. So my slope for this line would be 1/3. Now, if you had put it into this formula, you would have gotten 2 minus 0, which is 2, and you've gotten 4 minus negative 4, which is 6. So there you go. You would have gotten exactly the same thing, just in a very maybe more arbitrary way that's a little less easy to just see. Okay, so let's look at this one. How much did my y change? Went from 2 to 2. Well, that changed 0, nothing. And then how much did my x change? Well, it went from 3 to 2. So it went negative 1 in the negative direction. Well, 0 divided by anything is still 0. So a 0 slope, remember, is just a horizontal line. It doesn't have a rate of change. Well, it does have a rate of change. The rate of change is 0. So it's not changing at all. All right, let's look at this final one. We have our y changed from 2 to 5, which is 3. And our x changed from 3 to 3, which is 0. Oh no! This is where Slope Dude falls off the mountain because you can't divide by 0. It's a curse word in math, right? So this is undefined. So we have a vertical line. And it has an undefined slope. It's not 0, it's undefined. Okay. Now, one thing to remember is that parallel lines have equal slopes, meaning if one of them has the slope of 1/2, the other parallel line is also going to have the slope of 1/2 because, you know, they're two parallel lines going, wow, let's pretend that those are straight. Jeez, my pop socket is falling off of my iPad and I think it's really screwing with the way I'm drawing. Anyway, sorry. off topic. So parallel lines, they're two lines that are going in the same directions, and they never touch because they're rising at the exact same time. So they're in two different positions, and they never meet, which is sad because they have so much in common. Oh, cheesy math joke. Okay. Now let's look at perpendicular lines. Now remember, perpendicular lines have slopes that are opposite reciprocals, which means we change the sign and we flip them. Okay, so in this case, if you have a slope of 5/2, you change the sign, which makes it into -5/2, and then you flip it, which makes it into -2/5. So a line with the slope -2/5 is going to be perpendicular to a line with the slope of 5/2. All right, let's talk about how to write the equations of lines. There are 3 different ways to write them, and I will tell you that all throughout like middle school and stuff, you use this slope-intercept form, thinking that this was kind of like, the granddaddy of them all. But here's the thing. We don't use it very much anymore. I mean, like once in a while you'll use slope-intercept form, but most of the time in calculus, we use this form right here, this point-slope form. That's the reason why it's highlighted, because it's so important. We use it all the time. In fact, when you're asked to write the equation of a line on the AP test, and they don't say it has to be in points or in slope-intercept form, don't write it in slope-intercept form, because you know what happens is you start out here in point-slope form. You use this form right here, and you take this m and you distribute it in, whoop, whoop, and then you accidentally multiply wrong right here, whoop, and then you accidentally like add or subtract wrong here, and so your slope-intercept form turns out not being right, but your point slope was right. Guess what? You lose your point. You had the right answer, and then you tried to simplify it into something pretty that you saw all through middle school that you thought you needed, but you didn't need it, okay? So whenever you're writing an equation of a line, unless it's telling you a specific form, just leave it in point slope form, because it is so much easier, and it gives you all the information that you need. So let's write the equation of a line in point slope form, okay? So here we have a line that goes through the point 2, 3 and has a slope of -3. Okay, so we have point slope form is y minus y1 equals m times x minus x1. Now, I made all the pretty colors because I want to remind you the things that are in black are things that do not change. They stay inside of our formula just like that, right? And then the things that are in red are things that we plug in information that we know. Okay, so for this one, we're going to go y minus something equals m times x minus something. Okay, well, our m is -3, so we're going to plug our slope in there, and our x coordinate of our point is 2, and our y coordinate of our point is 3, and we are done. There is the equation of the line. Easy peasy, right? And just leave it just like that. Okay, now we're going to look at a vertical line through the point -1, 2. Okay, so we have this vertical line, it's going up and down, right? And then we have it going through the point -1, 2. So our coordinate plane goes somewhere around here, right? Okay, so let's look at this and decide, well, what's changing and what's not, right? Okay, there's all these equations out there that are like, if you want to write a vertical line, it's this. If you want to write a horizontal line, it's that. Don't have to memorize this stuff. You just have to think, right? So here we have a line. What's changing? Well, x is equal to -1 here. 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 But y is equal to 1, y is equal to 2, y is equal to 3, y is equal to 4. So y isn't constant. Y could change, but x absolutely cannot change. It has to be -1 because it's a vertical line. So this one is just x equals -1. All right, so now we've got a line that is parallel to a graph and goes through a certain point. So whenever we're doing something like this, we definitely want to make sure that we find the slope of the original line first, so that then we can write the equation. Okay, so we have a line. This is the original line, right? And we need to have the same slope as that. So we got to get it into slope-intercept form. In this case, you do need slope-intercept form because it's too complicated to get into point-slope form from here. So, oh, don't want that. Come on back. There we go. All right. So we are going to subtract 2x from both sides. So we end up with negative 5y equals negative 2x plus 5. We're going to divide by negative 5. And we have y equals 2/5 minus 1. So that is the equation of this line right here. Now we're going to use, 2/5 x. Where's my x? There it is. Okay. Now we're going to use the slope of this equation to write a line that's parallel to it. Okay, so we need y minus y1 equals m times x minus x1. Let's fill in what we know. We know the slope has to be 2/5. And we know it has to go through the point negative 1. So that becomes a positive and positive 2. So our equation ends up y minus 2 equals 2/5 x plus 1. There you go. Final answer. All right, let's do one that's perpendicular. Well, we already know the slope of this line, right? We know the slope of this line is 2/5. So to find a perpendicular one, we need to do the opposite reciprocal, so we need to flip it and change the sign. So that's the slope of our new line. And we're going to start by writing it in point-slope form because that's what we have. We have a point, and a slope. Now, it does tell us that once it's in general form, which is also known as standard form. You probably called it standard form too. But, so we're going to write this equation, y minus y1, which is 2, equals our slope, which is negative 5/2, times x minus x1. So this is in point-slope form. Now we just need to switch it into standard form. And to do that, we're going to distribute. So we're going to go y minus 2 equals negative 5/2 x minus 5/2. Add 2 to both sides. And add 5/2 x to both sides. Because we want to get all of the variables on that side. So we end up with y, or we'll just write 5/2 x plus y equals, what do we have on this side? We have negative 5/2 and positive 2. Oh, I forgot to do something, guys, on this last one. We'll go back. All right, we have positive 2 and negative 5/2. So this is positive 4/2. This is negative 5/2, so we have negative 1/2 left. Okay, well, here's the thing. In general form, we can't have fractions here. They have to all be integers. So we got to multiply everything here by 2 to get rid of the fraction, and we end up with 5x plus 2y equals negative 1, and that's the equation. Okay, now as I was doing that math, I realized I forgot something. Guess what I forgot to do? I forgot to read the instructions, and the instructions tell me very clearly they want this in slope-intercept form, not in point-slope form. Well, I did it in point-slope, didn't I? So all we have to do is we just have to distribute and get the y all by itself. So we still have y minus 2 equals 2/5 x plus 2/5, and then we just add 2 to both sides. And we have y equals 2/5 x. Well, 2 is really, what, 10/5 plus 2/5, we have 12/5. So there we go. That is the actual answer. All right, 2 more, guys. All right, we're going to draw the graph of this line. Usually when I see something in standard form, I'm going to use the cover-up method, but what we're going to find with the cover-up method on this one is that the point goes like way out here somewhere, so we're not going to be able to see it. So we're just going to switch this into slope-intercept form and graph it from there. So we're going to get y by itself. So that would be 3y equals negative 2x plus 9. Divide both sides by 3. We have y equals negative 2/3 x plus 3. So our y-intercept is 3. 1, 2, 3. And our slope is negative 2/3. So we go down 2 and over positive 3, right? Can't go down and to the left. You got to do one of them negative, one of them positive to have a negative slope. And then our graph is too little to graph anymore, so we're just going to make that line. And there you go. All right, last one. Y equals 2. I should hope to shout that this one's not too bad for you. Well, let's see. When we go to y equals 2, 1, 2, and our line stays at y equals 2 no matter what our x is. So this one's just a horizontal line at y equals 2. So I hope this was a nice, quick, and easy review for you of lines. I'll make another video about the calculator stuff at a later time, and hopefully we can get through this together.